Okay, let us continue this story. We're actually in pretty good shape now. Okay, we got these legs, they're hanging around. We have these parts you can put inside of other parts, and that, again, is really a very, very useful thing to do. You love the ability to put parts within other parts because you can start building things up. You can make, like legs or little table feet or all these little components that you then use to assemble furniture. So, for example, if you were a furniture manufacturer, you wouldn't have to start everything from scratch. You can make all the little subparts and start assembling them together, and it's very nice to do it that way. One of the advantages of taking parts and putting them inside of other parts is I can, for example, if I decide to change the look of that leg and make it square as opposed to round or add some special features to it, I just have to load it in once, and all the different other families that depend on it will inherit all the changes. So it's really a very good way to do it. The other really good thing about doing it this way, though, is this gives us that ability to go through and array things, okay? Because things that are sort of parts that are loaded in can be arrayed nicely as opposed to things which are extruded, which always give me trouble when arraying. So let's see if we can kind of come up with a rule that'll sort of determine what wants to happen here. My goal is I'd like to go ahead and take these table legs, and I'd like to, instead of doing it this way, I'd like to actually create an array of table legs so I can put some number of them between this end of the table and that end of the table, and then have the number that's arrayed somehow be smart about how many it's going to put in there. So let me go back to the reference level and kind of see how we can do that. Okay, so here's the deal. I've put all 4 of them in there kind of manually right now. Let me go ahead and knock those 2 out for a second. Because I'm going to think of this as just being a pair, and we're going to array it along however many pairs we want. So what I want to do is actually kind of create an array, and when we're creating arrays, there's always a couple ways we can determine them. We can say, let's go ahead and put an array by choosing the next increment and then having as many as we want. So we kind of do it that way. The other way we can do is take this pair and put it at the end point and say, give me even increments between that. Sort of subdivide the space into a whole number of spaces between. And I'm going to use the latter. I'm going to put it on the end because I know where I want the last one to be, and the middle ones can kind of float depending on the length of the table. Okay, so let's see if we can make this work. I'm going to grab this guy and that guy. Again, I'm grabbing my 2 little table legs. I'm going to go through and create an array. When we array, we always have the choice of move to the last or move to the second. I'm going to say move to the last. There's this whole idea, should they be grouped and associated? That I'm going to leave turned on. That means that it's not only going to copy them, but it's going to keep them linked together. So if I make any change to any of them, the clones will all change. So if you turn that off, it's just a copy. If you turn that on, it's a clone. Okay, so I'm going to leave them cloned. I'm going to say, great, I'm loving this. I'm going to grab that first one. I always have to choose some sort of point, some reference point. Actually, even just do that if I want to. I'm going to drag it along to where the end point is. Looking pretty good. Okay. There is a number here. The number right now is currently 2. I'm just going to leave that hanging for a minute. Let me see if that actually is going to pick up the locking constraint the way I want it to. If not, I'll have to lock that in there. Let me change that length to 15 feet. Okay, roommate constraints are not satisfied. It's a little confused. Oh, that's interesting. It's because of the way I defined. That's funny, because it's going to change in 2 dimensions. I'm going to undo that. What do I have to do? I'd have to make an array and an array. Well, maybe I'll do that. It's because the array has a set distance. The ones in the array have a set distance between them, and I haven't actually built that set distance in, whatever. I need to build that in. Hang on, let me cancel that. I'll be smart about this. Okay. Back up. Even back up over there. Let me ungroup those things. It's going to make me be smart about this, but we'll go ahead and do it. Okay, basically the distance between this one and this one, even kind of remove that for a second. If I'm going to go resizing this and have this all controlled parametrically, the location of the second leg is actually going to be determined by a couple different things. One is it's going to be aligned with that reference line right there. Okay, that part's kind of good. The distance between those two from here to here, if I'm going to allow the depth of the table to resize, I'm going to basically have to have a parameter that's driving that too. So what I would do is I could say, let's put another annotation. I didn't mean for this to get complicated that way. I should have just done it in a single dimension. But since I went down this hole, I'm going to try and fix it for you. I'm going to put a dimension between the table legs. Okay. And now that dimension should be we're going to let that be table leg width is always equal to the table depth minus 4 inches, or 8 inches, excuse me. It's complaining yet. There's no table in that word. Thank you. Okay. Hopefully that'll be a little smarter now. Let's just kind of check that out. So if I say that the table length is now 15, okay, those are moving smartly. Okay. The problem is, yeah, if something's arrayed, you can't sort of change things inside the array at the same time you're changing the array. You kind of have to, if you're going to do it, you have to control it programmatically, and that's what it was sort of complaining about. So given this, now I should be able to take these two and array them. Okay. Reverting to what we said a little while ago. I grab the middle. I'll go ahead and put it on that guy. That should be fine. Let's check it out. I'm still complaining about something. What's it complaining about? It's not liking that side over there. Well, I'm going to cancel that for a second. I'll work on fixing my story. It's something about the second leg over there. But I'm not going to let that dissuade us from the issue of zoom to fit. I'll just do it with a single one as opposed to multiple ones. I thought I was going to get solved right there. I'll take you and put you over to here. Okay, that should be fine. Let's try that. Again, general principle is if it's giving you trouble, simplify. Keep on simplifying until you can find something you can control. That is interesting there. That's the endpoint of the array. Ah, okay, we can fix this. Notice the endpoint of the array didn't sort of move the way we wanted to it. No worries, we will align that line to the middle of that one. I'll align this one to the middle of that one. Okay, so now the endpoint of the array is locked, the front of the array is locked, and everything in between should follow. So if we do this, up to 15, okay, up to 20, okay, so let's talk about that for just a second. The key, just so you didn't go by too fast, is I made a mistake at first, and I often make mistakes as we're doing this stuff, but they're easy to fix. Okay, at first I hadn't actually locked that to a specific location. I just kind of put it on top of there, but it wasn't actually locked. In fact, what I probably should have done was just my general rule about what I do with masses. As opposed to trying to put it right on top of it and cross my fingers and hope that it's locking, actually put it someplace else and lock it manually. So maybe I'll do that again because that's probably a smarter way, so you'll capture that on video, and if you have to sort of see that again, you'll see how to do it the right way as opposed to my fumble around way to do it. So I'm going to again take that out. Okay, as though we were starting from scratch. Come back over here. I'm going to take that guy. I'm going to array him. Take it over to the endpoint. And I'm just going to put it somewhere. I'm not going to put it exactly where I want it to be. Okay. The reason I'm not going to do it is I want to get it explicitly locked to there. So now I can go through and do the alignment, aligning. I always want this to line up to the center line of that, lock that in place. And I always want this one to align to the center point of that and lock that in place. Okay. Now, without a doubt, they're always kind of locked in place. Okay, so those two things are going to move. Okay, so what always happens is it just sort of splits evenly between arrays think they have an endpoint, or start point they have an endpoint, and it'll just sort of scatter things along the path between the two. So this actually makes sure that the endpoint and the starting point are always precisely where we want them. Okay, you say that's looking pretty good. Let's go ahead and control this. Zoom on out. You can take an array. See if I can grab the array. Little tabbing will usually do it. See if I can get that array selected. Oh, so there it was. It's kind of hiding from me there. The array actually has a number in here. In this case, 2 is the number of legs that it's putting in. 1, 2. Okay. I can change that number, make it 3. I can change that number, make it 4. Whatever number that I want to put in there, I can go and put in there. So again, grabbing it, there's the array number. That's called the array num. If you would like to sort of make that array num a parameter so you can actually have that change as part of the formula too, you can do that. A little hard to select, but let's see if I can make it get the selection for you. I mean, you know, this is wireframe. Let's see if I can kind of make it pop out. The line is actually right there. It's kind of hidden from you. But I want to select the line the same way I would select a dimension. Okay. And add a parameter to that. Okay, and I'm going to call this the number of legs. And why am I doing this? It's really, I'm just trying to give another level of parametric control. Okay, so if I take that, again, it's a little hard. You have to grab the array and get the line and say add a parameter to it. I'll say let's change those properties. Number of legs is in here, so now I can change that programmatically, like 5 or 8 or whatever I want to have happen here. Okay. So as my pool table gets longer, I can add more legs. As my very long dining table gets longer, I can do that. But now I can go through and also go through and put a formula in there. So for example, I could say, let's take the length and divide it up by some increment. So let's take that length, and let's say we want a leg every 4 feet or so, something like that. In that case, it's nice and even. Let's try 22. That's interesting. It looks like it's actually doing the right thing, which sort of surprises me because it doesn't always do that. 20 gives us an even 5. 21 is giving us 5. 22 is giving us 6. 23 is giving us 6. 24 is giving us 6. 25 is giving us 6. 28 is giving us 7. Okay, looks like it's rounding. Okay, that's fine. So if it's a little over, it's rounding down. If it's a little under, it's rounding up. It's doing that. We can decide whether we want that to be a rounding relationship or if you want it to be an integer relationship. There's any number of ways. Depends on how you really want to handle that. So if it's a little bit more than 4, do you want to put the 5th one in there, or do you just want to kind of round it off? Either way, you just sort of get a choice about those. If you'd like to do the other way, like this is rounding, if you always want to make sure that it's a minimum of 4, and as soon as you get to the next one, it would have to add another leg in there, or the maximum of 4, you would put in, and I always have to remember if it's int or integer. I think it's integer. Or int, excuse me. Let's see if that is it. Nope. Okay, as usual. Oh, come on. What is it? If it's a little hard to see, we'll go back to the slides and see if I can remember in here. I don't have it there.
Probably the space between parentheses and space.
It could be. No? Okay. When all else fails, do what no one ever does. Go to help or something like that. Sure. Conditional statements using formulas. Conditional statements, resizing, valid formula syntax, blah, blah, blah. Length, round, round up, round down. Round up returns a value to the largest integral value, blah, blah, blah. So round up of 3 is 3, round up is 4. Okay, that's good. That's actually sort of what I wanted to do. I always wanted to go to the next highest one. So looks like it's not an integer anymore. It's either round up or round down. So if I had 3.1, it would up to 4. If I had 3.2, it would up to 4. If it was 4.1, it would up to 5. So it always rounds over as opposed to rounding down. So let's do that. We'll come back over in here. I'll say that's going to be round up. Length divided by 4 feet. Say OK to that. And with this fancy formula in place, if I go through and make that thing, 36 feet long, you get a lot of legs. If I go through and make that 12 feet long, you get a short number of legs. Can you do the same thing on the backside too? But that's really the essence of, that's how all that panelization happens. It all happens through that sort of stuff. Okay, so let me pause there and hopefully kind of put that one aside. How's that sort of feeling in general? That's the most complicated thing. And again, don't think that for assignment 3 you have to have parametric arrays and all that kind of stuff. For what you're doing for your assignment, just as long as they're resizable in some way, we're happy. Okay. If you have a material parameter in there, we're very happy. You know, if you're having arrays and things flying around, you've blown it out of the water. You don't need to do that. So don't think that just because I'm showing it to you, you need to do that. Okay, but I want to always give you how far you can push it. So even if you don't do it this time, it's planted in the back of your brain and you sort of know, oh, I could do that. So later on you can review this. So does that feel good? Beauty.